All right, class, here we go. Today is the 23rd. Need all this stuff out there, simple as that. Get to page 8. Remember, this is a video. Pause it whenever you want. Rewind it whenever you want. Okay, so vertical translations. Okay, vertical, that means up and down. Okay, just so we're clear there. We're gonna talk about how these parabolas move, okay, like as they move in a way, right? So yesterday we looked at the graph of the parent function, okay, f(x) equals x squared. Today we're going to see how to make changes to this equation and how they affect the graph. So first we're going to start by just completing this table, okay? So f of x is x squared, that's this one, right, x squared, okay? And the other one is x squared plus 3. So you're going to pause the video and fill out all of these boxes here. You can use your calculator, type things in. Hopefully you actually paused your computer, because otherwise, why? Like, you can just copy this thing online. It's just silly. It doesn't make you any better. So make sure that you got these things figured out yourself, not just copying from me. Okay, so you should have all those things. Well, how do the values of f(x) and g of x compare? Well, it's pretty simple to look at. What happens every time, right? Every single time, what happens? G of x is 3 more than f of x. Makes sense, doesn't it? Isn't that the only difference in the two equations, the two functions, right? It's the only difference. So there you go. All right, sliding down here. So we're going to graph this function, g of x, okay, the one from above. And I'm going to graph f of x also, by the way, okay? So I'm going to graph f of x first. So I'm going to graph that there. There we go. You should spend the time graphing these, not just copying my graph. That doesn't actually help you. Okay? You checking to see if you get it right, that's going to help you. Okay. So right here, in orange, that's f of x. And then I'm going to do in blue here, the g of x. Okay, so g of x right here. Okay, so you spend all the time graphing those. And there we go. So the g of x is the blue one. Okay. What's the vertex of g of x? Of course, that's this point right here. It's at 0, 3. We have seen this 3 before. This 3 right there. We have seen this 3 before. It's this 3 right there. Okay? Not a coincidence. All right, what's the axis of symmetry? Remember, that's an equation. Okay? So that is going to be x equals a number. That number, well, let's actually draw it in here. Okay, the axis of symmetry is right here. Come on. That's the axis of symmetry. It's the line x equals 0. Again, we have seen this number before. Okay, this 0. This 0 is the same as that 0. They're the exact same thing. Identify the domain and the range. All right. So the domain, let's put a D with a colon. So we don't have to write the whole word domain, but D with a colon's fine. All real numbers. Okay. And then the range, well, the range we have to think a little bit more about, right? The range, remember, we're looking at g of x. Think about this horizontal line right here. It doesn't even exist below here, right? It doesn't exist at all. It only exists above this line. That line is at 3. Y is, because range is always the y's, y is greater than or equal to 3. Again, that 3 we have seen before. It's the same, it's the same as this 3 right there. Same 3, okay? Same 3 as above here in the original equation with g of x. Predict what you think would happen if we graph the function y equals x squared minus 3. Let's think. Let's look at our g of x here didn't this thing go up 3, right? And g of x was x squared plus 3. Makes sense. Plus 3, up 3, right? Well, what do we think a minus 3 is going to do? You should pause the video and predict, and then look at this. Down 3 from f of x, of course, which is the parent function. So we went down 3. Makes sense. Negative 3 means down 3. Makes perfect sense. Next page. Okay. So here, for this, we're going to draw a little, in this like summary box, if you will, draw a little coordinate plane, okay? We have f of x, okay, the parent function. But I'm going to draw this here. I'm going to call this one g of x, okay? And I'm going to draw this down here, h of x, okay? So you should draw each of those 3, label them as well, okay? Label them as well. Should have arrows on them, and all the things that we've been talking about. Okay, now on the left-hand side, I'm going to talk about g of x. I'm going to do it here. G of x is equal to x squared plus k. We use the letter k for this particular spot. We'll talk more about other things we'll deal with later. Don't worry about it. We used to use the letter k. See how it's up, it's above, okay? This distance here is k. Also, the y value up here is the y value of k, okay? Then on the right-hand side here, h of x, put it down here, h of x is equal to x squared minus k, okay? Minus k. That means, so however far this goes down from the parent function, that is a distance of k, so this here is that negative whatever k is. I don't know what it is, but it's something, okay? So the minus k, that means move it down k units, right? And the plus k means up k units. So we say a parabola moves, that means it goes up or down. We'll learn other movements later, but today, just up or down, just vertical translations like we talked about. Translation just means you move it, okay? All right. You do have this page as homework. Okay, plus there's something on Schoology to do. So make sure those get done. But this video isn't over, as you probably have noticed. Okay, we're gonna go through this page 10, this review. Okay, we're gonna go through this page to review things, simple as that. All right, here we go. I suggest, by the way, you pause the video. Pause video. And you should try all of these problems and then see how you did. Okay, so here we go. So it should be paused. Why haven't you paused it yet? I'm just joking. Hopefully that was funny to you. All right, here we go. Hopefully you paused it, you've got some answers. Here's what we got going on. In here, -2, -5, -6, -5, and -2. You see the symmetry again? We're talking about that a lot, haven't we? Now we got to graph those points. -3, -2. -2, -5, there we go, there we go. It's these points here. There's your parabola. That's what it should look like. Sliding down, should have these done, okay? The vertex, which is right here, okay? That is at 0, 1. Axis of symmetry is x equals 0. Remember, the axis of symmetry is the line that goes right through here. In case you're thinking, how do you know? Well, you have to look. This obviously is the y-axis, and this obviously is the x-axis. So here, that's the y-axis here now, right? And the x-axis is here. You have to look in case that's confusing to you. The vertex here is right there at that point. That is at 3, 0. Axis of symmetry is x equals 3. A reminder, this 3 in the vertex is the same as that number right there. Same thing with this 0 and that number right there. They're the same thing. Not a coincidence, happens every single time. And this next and last problem, there's the vertex right there. It's at 2, 4. So x equals 2 is the axis of symmetry. Again, that's this line that goes right through the vertex, right through the middle, cuts it exactly in half. All right, next one here. The graph of a quadratic function g is given. So this is our g of x. Okay, that's our g. We got to identify the axis of symmetry. Well, the axis of symmetry is this line that goes right through the vertex, right? And it's always this x value. X equals 2. That's the x value of the vertex. All right. We've got to find both x-intercepts. Well, one x-intercept is easy. Like that's it right there. -1, 0, right? It's right there. I can see it across the x-axis. The other one, I know it's right here, but it's not labeled for me. Is it this point 4 negative? No, it's not. It's not that point. That point doesn't cross the x-axis. That's what x-intercepts are. So this other point that we don't quite know yet, or do we? Well, we know this blue thing is called the axis or line of symmetry, making it exactly symmetrical. So what's the distance from here to here? So from here to here, that is 3. In case you're like, how do you know it's 3? This is at -1, right? And this is at 2. How do you get from a -1 to 2? It's 3. So if that's 3, that means this has to be 3. So how far is it? Well, it's the 2 plus the 3. That's at 5, the x value of 5. And of course, 0, up and down 0. So 5, 0. That's how you figure it out. Okay, this thing is symmetrical. We can use that to our advantage to find things. All right, next one here. The graph of the parent function, f of x equals x squared, is drawn below. So these are both f of x's, okay? F of x, that's what that is in black, okay? Make a sketch of each transformed function on the same graph. So we got h of x equals x squared plus 3. This plus 3 is what we've been talking about. What does that do? It makes it move up 3. 1, 2, 3. And just draw in the parabola. There you go. That's h of x. That's all you do. Don't overthink it. It's not supposed to be hard. This one here. This is f of x, okay? The black thing that's drawn in for you. And we are going to graph g of x. G of x is x squared minus 2. The minus 2 is what we've been learning about. That means down 2. So the vertex is there. Just draw in your parabola. Doesn't have to be perfect. Did I take a lot of care into drawing it? No. But it looks like a parabola, so that's fine. That's g of x. All right. That is your lesson today. Remember, you have homework and something on school to do. And of course, these pages got to be done. Have a great day.